AMC8 is let's talk about this thing one by one. First, we're gonna talk about all the homework lesson. My club has 15 members. In how many ways can we choose a president, vice president, secretary, treasurer if no number can hold more than one office? Okay, so for the president, the Mr. President Trump. Okay, yeah, Mr. President and the vice president, vice president. Who will be the vice president in America in the future? Okay. You already give me answer, so I'm gonna put it in. Okay. Yeah. Let me check if that's a right answer. Can I be the vice president in America in the future? 32760 ，OK。32760 ，OK。OK, no problem. 哇，genius. You can't hear anything? What? Let me check. Can you hear me? 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 Yeah, okay, cool. So this is talking about, I can hear him. I think it's a personal computer isn't for him, IDK, okay. So this is a president and vice president, secretary, treasurer. I think, can I be the vice president of American? Maybe in the future, I can in that mode, yeah. And I will change my family name into Hu, you know, like the Hu Xijin, something like that. My family name is Hu, so I gonna have my slogan called "Who cares?" Okay, yeah, because I care about you, so I said "Who cares?" Okay, yeah. Yeah, that's a funny joke. You get it. Okay. You get it. Yeah, who cares? That's the campaign slogan. Yeah. But that's I've changed my family name into Hu. So there's a who cares, not a who cares, man. Okay, so let's go back to the question. No more jokes, okay? Yeah. There are 8 sprinters in the Olympic 100-meter final. So the gold medal goes to first place, silver to second, and the bronze to third. Yeah, very reasonable. So in how many ways can the medal be awarded? You said 336. Okay, I'll put it in. Yeah. Because this is a homework I think you have already done, right? So this one is 878 because 876 because we have 8 sprinter. The first one, with first slot, we have 8 choice, 7 choice, and 6 choice. Cool, man. 1.46. That's a good review too. Yeah. 8 factorial divided by 5 factorial. Man, you get it. Yeah. Suppose I have 6 different books, 2 of which are math book. How many ways can I stack my 6 book on the shelf if I want a math book on both ends of the stack? $48. Okay, I will try 48. Yeah, answer is 48. Because that's you get why is this a 214321? Maybe some students don't understand. You can think about this because in the first slot I only have 2 choices. At the end of the slot I only have 1 choice because they have 6, and in the middle I have 4 slot. If as I choose the one of the math book and the rest of the 4, 3, 2, 1 choice. So it's a 4 multiplied 3 multiplied 3, 2 multiplied 1 multiplied 1 multiplied 2. We got this one, 48. Okay, cool. And 1.45. How many ways can I stack 5 books on the shelf? Yeah, no problem. 5 factorial, 120. Low problem. Very smart one because it's also the homework we do. Okay. And also lessons plate with a 3 letter follows 2 even digit. followed by 2 odd digits. So consists 3 letters. 2 even digit, 2 odd digit, 3 letters. This will be a big number. 26 power of 3 multiplied 5 power of 2 multiply with 5 power of 2. No problem. No problem. Lice. 109855000. Sounds like a phone number. 109985000. No problem. I'm typing phone number. Okay. Yeah. It's like a phone number. Okay. 1.443. How many license plates consist of 2 letters followed by 3 digits? 26 power 2 multiply with 10 power 3. Sound like it's some kind of the TV shopping hotline number. Yeah. There's a 26 power of 2 multiplied 10 power 3. Nicely done. For each of the 8 colors, I have 1 shirt and 1 tie of the color. How many shirt and tie outfit can I make if I refuse to wear a shirt and a tie of same color? 56. Okay. 7856. Okay. How sour Goodman for insurance? Okay, okay, no problem. And because it is he refused the same color. So if you choose one of the color for the first slot, then you only have 7 color in the second slot. So how many shirt and tie outfit can I make? No problem.
Excuse me?
Yeah.
Excuse me? Can you let 1-29 Mingzhi come in? I think he's in the waiting room.
Yeah. That looks like that. Okay. Okay. Let's let's go to 1.5. Let's go to the permutation. This one will be a little bit abstract. Let's think about the first question. A club has n number, where n is a positive integer. We want to choose R different officer of the club, where the R is also positive integer, such that no member can hold more than 1 office. In how many ways can we fill the first office? Your answer is? No problem. A is n. Oh, someone already gave B. Oh, n minus 1. Once we fill the first office. Okay, the B question, think about it. The A is n. According to what we learned last time of the choice, for the first slot, it have n choice. For the second slot, how many slot? How many? Oh, someone don't know how to get n minus 1.
Excuse me?
Yeah?
He's still not in.
You are still not in?
No. 1-929 Mingzhi still not in.
Oh, I see. Let me check later. Let me talk about this question first. In how many ways can we fill the first office? Yeah, because they have the R slot. I think the number is R. Maybe plus blah 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 blah. Have this much of the slot. This R number of the slot. And for the first, because we have n number, right? N member. So first slot, we choose n. But for the second slot, because this one is already have one inside, so the next slot we have n minus one. Okay. Let me check who is outside. I will save this picture. 还有人要进来吗？ Let me check. Okay. Okay. I will let them in. Okay. Sometimes I just focus on the class too much. I can't see that simultaneously. C is n minus R plus 1. D is gosh. I think C is good. But D, think about it. Let's try question C. The question C, someone said n minus R minus 1. Okay. Okay. Give you one more 10 seconds to think about. How do you get that? Yeah, someone asked, how do you get the C? Yeah, someone see the C, but someone don't get why they got the C. Let me explain. Okay, let me explain how we get the C. Now, actually, some students, they were, if you join the now, it's not a bad time. Okay, because that's we just started 1.5. We have just finished the homework last time to talk about the homework last time. Okay, think about this part. We have R slot, right? For the first one, we have n choice. The first slot, n choice. And the next, you only have n minus 1 choice. And the next one, you have n minus 2 choice. And blah, 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 blah. But we only have R slot, right? So inside, in the last one will be how many one? How many one? N minus how many? N minus R slot, N minus R choice. Because you can think about this. Let's think about if we have 5 box. Let's make it into more concrete box. 1, 2, 3, 4, 5. Okay, but now I have for example, I have 10. I have 10 member. Choose 5 officer. So the first slot, I have 10 choice. Because I have 10 choice to be the first office. I have 9 choice to be the second office. I have 8 choice to be the third choice. I have 7 choice to be the fourth officer. And I have 6 choice to be the final officer. Okay, the 5th officer. Now think about this. 6 equal to n minus R, but plus 1. You can think about this. The 6 equal to 10 minus 5 plus 1. So in here, also in here is a plus 1. Okay, n minus R plus 1 is the final officer in here. So now how many choices do I have? We have n multiply n minus 1, multiply n minus 2, multiply blah, 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 to n minus R plus 1 choice. That's what we done. Okay? You understand? Guys, from this example to mimic this example, I think this one will make you fully understand what I mean. Let me check the chat box to check if you understand. In here. I got it now. Okay, cool. Oh, nice. I thought the order of the toys don't matter because they are all the same officer. The problem never said that officers are different for D. Okay. In how many also think about that? So the officers, right? So it said there's a choose for different officers, right? The question said they're different officer, right? Because they're you said okay, the 5W, the 5/297 said there's they are all the same officer. No, they're not same officer. You can see that the question give us are different officers. So the different means that so the sequence is important actually. Yeah. So IQ 200 plus is a real so Death Note. No. We don't talk about anime in here, okay? Kira from the Death Note. Actually, I have a note. It's called Death Note, and I am the Kira. Okay, you know, and some detective called L is hunting on me. Okay, yeah. I'm a big anime fan. Bazinga! Ha! You didn't exactly that, right? Yeah. Yeah, rest in peace, L. Oh. don't talk about anime anymore because I don't think all the students understand what is the anime you are talking about. This will be too narrow. Yeah. LOL. Okay. Let's go back to the question. No more anime time. Okay. Wait, no, I just realized that I lost my host power. Okay. Yeah. So let's go back to the question. Yeah. If we process the A and B, how many ways we fill the R's office will be N minus R plus 1. So how many ways can we choose for R office? Okay. So let's see this deduction. Okay, so let's see this deduction. The deduction said we have N multiply N minus 1, N multiplies 2, N multiplies N minus R plus 2, N minus R plus 1. So we have this kind of fill the office. Okay, so fill the office. The previous will be the N minus 1, N minus 1. So this the quantity is called the number of the permutation size are from the nth object. This is called PNR actually. How do they get the PNR for the n factorial divided by n minus r factorial? They use this kind of technique. They continue to do the n minus r. The next part will be the n minus r. And the n minus r minus 1 multiply 3 to 1 until the end. And you can see the numerator will be the n factorial, and the denominator will be the n minus r factorial. Okay, so this is a PNR, not the CNR. I see some students who see tell about the CNR, like the 5/William. If you use the PNR, this will be a combination thing. So that's means the inside of the sequence is not important. If you're the same officer, they will be supported your conclusion. You don't know how this works. Let me show you this a simple example. With the example I have already done in here. Let me show you. Okay, so in here we have, if we think about the 10-member 5 office, we have 10 multiplies 9 multiplies 8 multiplies 7 multiplies 6 choice. And I can do this. I can multiply one thing is called 5, 4, 3, 2, 1. And 5, 4, 3, 2, 1. Okay. Now I can read, right? Because this is the numerator denominator is the same. It's just to multiply 1. Okay. So I can write this thing as a 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, and 5, 4, 3, 2, 1. And for the up is a 10 factorial. For the bottom is 5 factorial. So in here I can write it as a p. You can write it as a p10 comma 5. I'll write it as a p10 5. That's called the 10 factorial divided by 5 factorial. This is a 10 member and 5 officer. So mimically we can do this. We can do this version is a very complicated version. It's a p. I can write this up. We have the how many number do we have? We have the n number. So we can write this p n comma r. So it's a n factorial divided by n minus r factorial. Okay. Actually, here is a n minus r factorial. But this one is just a. Well, this is a 10 minus 5 is also 5. Should I choose the 4 will be more clear for you if I choose 4. Yeah. Maybe I should choose 4. Let me choose 4. This also works. Let me choose 4 for you guys. Like the 10, 9, 8, 7. I have a 4 officer. If I choose 4, so this will be shorter. This is only 8, 9, 8, 7 choice. Okay, 8, 9 for choice, 10 for this one. So I have 8, 9, not 6. Okay, so I have the 6 in here, 6 in here. Okay, so I have 6 of 10, 9, 7, 6, blah blah blah, and in here is 6. So I have a 6 factorial divided by 10. So this you can see this so is a 10. Actually, this 10 4. Okay, we're on 4 choice. And think about why this is 10 4. The 6 factorial equal to 10 minus 4. 10 minus 4 factorial. And here is a 6 factorial. Okay. So that's why. That's why you can think about this thing. This one is a simple version, but this one is very long version. It's just you can choose to think about the version our book give us. Yeah, like this one. I don't get how this work. Yeah, but how does this solve a question? Okay, good question. How does this solve a question? Let's think about the question last time we have for the question 1.4. Actually, we can use this formula to solve a lot of questions in this chapter. So in here, like you have 20 member. How many ways to select a president, vice president, treasurer, if no one can hold more than 1 officer? So that's like a 1, 2, 3. We have 3 slots. We care about their permutation, right? So we're not just random choose different guys. So we can use our calculator because we know this is a permutation question. So we can write like a P20, and how many choice? 3, P23. So this gives us 6,884. Let me jump to the solution. Let's check. 6840. That's the answer. Yeah. So we can use this as a permutation to solve the question last time. What if my calculator is not advanced enough to do that? Which calculator do you use? I want to know. Basically, for the student, we have some choice. Let me show you my calculators. I have the Texas Tech, I think 20. I think Texas Tech have this kind of function. Oh, why I close my camera? I don't know why. Let me 怎么把我这个变大一点？好 how to 呀？ how to 把我变大一点？哦，算了，那就这么小。We have the Texas inspire. I think this one is for the AP calculus. Yeah. And this one can do the permutation combination. Yeah, they can do. And also I have a Texas TIH4 plus CE. This one can also do the permutation combination too. Yeah. And also I really prefer the FX991. Yes, FX 991. Wait, where is my FX 991? Okay, in here. Yeah. I have my FX 8991. This one's for Casio. And so very easy to use for the student to use. I think this one's pretty good. Yeah. Okay. So anyway, if you have a calculator, you can always find the sign P4 in here. Okay, let's solve more questions use this way. Like this one is not a permutation question. It's considered 2 letters, 3 digits, because this one's you can use that number repeatedly. This is different from that. Like 2 letter, you can say 2 letter. First choice we have 26, and the second choice we have 26. And this is the first one we have 10. Next one we have 10. Third one we have 10. Unless they said the 2 letter, the first letter you use one of the letter, you cannot use that letter again. You use 1 digit, you can use that digit again. So you can use permutation. This is different. Okay, remember the difference. Like for this one, we have a 15 member, right? We want to choose a 1, 2, 3, 4, the full officer. We can just use that knowledge, because we know this thing is a one of the slot being occupied. It cannot be occupied again. So I choose P15 4. So I got this thing 32760. And like is an 8 sprinter 100 meter. The gold for gold. We have 8. Yeah. And we know that every slot can be only used once. Put 336. Okay. Very smoothly, huh? Yeah, guys. Yeah. Let me check your reaction. Texas 20, I got Texas I20 or something. Just search up the permutation calculator. No permutation calculator. You can use the simple calculation. If it does not use a phone call, that's I use a TF. Okay, influence. Okay, cool. Like okay, cool. Let us go back to our 1.5. Let's go back to the past. 1.5. Okay, so we have done 1.15. Let's go to 1.16. My city is running a lottery. In the lottery, 25 balls number 1 through 25 are placed in a bin. Okay, 4 balls are drawn one at a time, and their number are recorded. Okay, the winning combination consists the 4 selected number in order they are selected. How many possible winning combinations are there if each ball is discarded after it is moved for the first one? Okay, someone already? Cool. Can you give me the number? Exactly number. You can use your calculator, I think.
I got a question.
Okay, no problem. Ask.
So like I saw a lot of people is like writing 25 times 24 times 23 times 22. Why?
Yeah. Yeah, because let me show you. In here, it's for the question A, for the question A, it said that each ball are discarded after it removed. Yeah, but like you have 1 to 25, and just like in here, just let me show you with the slot. The first slot we have 25 choice, because think about it, that if you choose 25, so the 25 disappear. Okay, you only have 24 choice in the second box. In the second box, if you choose 3, then 3 is discard. So 3 and 25 disappear. So for the next box, you only have 23 choice. And if the third box, if we choose 1, so 1, 3, 25 discard. So now we only have 22 choice. That's why they multiply together. And also think about this thing. Because the discard, will never repeat again. So we can think about this permutation question, like I showed you. You can use a P25 fold as this kind of way. 303, 600, like this one. Okay, let's do the question B. I think someone already done the question B. Nice. Mm-hmm. Mm-hmm. Mm. The B said each ball is replaced in the bin after it's removed before the next ball is drawn. So this will be the 25 power of 4. 390,625. Okay, most of the students got 390,625. Really? 还有人等候。Let me check. Why 还有人等候？让我看一下啊。怎么还有人迟到这么久啊？Why 呀？Wait，要不是我刚刚看那个 chat box，我都不知道还有人在等候。OK， Okay, I will give you all guys this question. This. Okay, cool. Because it's removed and replaced the bin. Okay, they put it back, so that's they have 25 power of 4. Okay. Oh, that's done. That's done our example. Compute the following. What? No hard at all, right? You can use your calculator to do this. Okay, like this way, right? 3. So calculator times, guys. Let's do this. If you don't have calculator, you can use the traditional way, like the 8 factorial divided by 8 minus 3 factorial. You can do like 8 factorial divided by 5 factorial. It's 876. You multiply 876, you got 336. This also works. You can use calculator to give 876. Okay. Okay, so soon. Someone already got E. My gosh. Faster. But give more time to other students to do this permutation question. TI conspire. Okay. Okay, I think most of students done this, so I will choose some students' answer. 16280, show solution，show solution。然后哎，这个简单，这个就是30啊这个就不看死就是。然后这个是哇，这是6543啊，这个看一下 solution student 720，1700，没有问题。然后这个是最后一个学生，超一个学生，117600，OK，show solution。Nice.
I feel
You
like
guys
to
are
solve
genius.
P, I feel
Yeah.
like to solve P, you just multiply the first variable by the second.
Yeah. Yeah. The like is if you are really familiar how to do this, like if 50,3, you can think about this. Only three of the countdown only first three. 49, 48. It's okay. Yeah. You guys are smart. You are genius. You know. 你们是基尼伊斯的基尼伊斯的哥哥基尼太美。OK. You know 基尼太美? Maybe you're not familiar with the Chinese culture, right? Yeah. Okay. Yeah. RIPL. Okay. What is PNN for the positive integer n? This one. Start. Someone said 1, someone said n factorial. Which one? Most of the people said 1. Okay, let's do a trio. Let's do a little experiment. Let's try P66. Is that 1? Unfortunately, it's not. Unfortunately, it's not. Actually, this thing is equal to 6 factorial. Where's my factorial? 那 factorial 的键去哪里了？哦，在这里。Okay, factorial. Yeah, they're equal to this. Like another experiment, like 9. Let's see the 9 factorial. The same. So this one should be n factorial. I think the deduction is not hard at all, too. You use a formula, huh? There's an n factorial divided by n minus n factorial. It's equal to n factorial divided by 0 factorial. 0 factorial actually is 1, okay? So n factorial is equal to n factorial. 0 factorial is 1 because in that 0 slot, you only have one choice, right? 如果它只有0个 slot, it's a 0 slot. You don't have any choice, so only one choice. You understand, guys? Let me check your reaction. Chat box. What? Let me check the chat box. Chat box. Okay. That makes sense. Now is not making make sense to you? 166. Kind of makes sense. Okay. Oh, it does. Okay, cool. Obviously, this thing makes sense to you. The 0 factorial is 1. Okay. Because there's a no choice means only one choice.
No choice means one choice doesn't make sense at all.
You have no choice is one choice. There's a only one choice is no choice. No choice is also
oh,
a
wait,
choice.
That makes sense.
Yeah, that makes sense. No choice is a choice too. Okay. Like you have A, B, C, D. Yeah. Like you have if choice A is 3, B is 2, C is no choice. So you can choose C is also a choice. My brain is negative. Okay, no worry. You can remember 0 factorial is 1. It's okay. Yeah. In that 0 slot, there's only one choice. I have dementia. What is dementia? What's that word mean? It's really fun. I don't understand. It's when you forget stuff easily, memory lose easily. Oh, dementia is that thing. Okay, yeah. Okay, let's go back to our question 1.53. We have 12 balls, number 1 through 12, are placed in a bin. In how many ways can 3 balls be drawn in order from the bin? Each ball remains outside of the bin after it is drawn. Okay, very smart. Someone's already got the answer. Yeah. No problem. I think no problem. If you finish the first one, you can do the second one. Okay, I think most of you have done. So I will choose one of the answer from our student. 1320, 1728, 1584. Let's check them one by one. For the
How
first,
does 1584 work?
I will explain one by one. Let's check. Nice. Nice. Okay, I think all of the 3 you got the right answer. You are killer. Okay, nice. Some of our students are pretty good, huh? Yeah, those are like a little genius. Let me show you one by one. For the first one, it's the easiest. We have done this a lot, right? It's just do not put outside, it will not go back. So the first 12 choice, because the first one already take out, this will never in, right? So the second only have 11. And because the second one have already take out, it will never go back. It's a 10 choice. Multiply, we got this 13220, 13220, 1320. And each ball is placed back into the bin immediately after it's drawn. So the first one you take out, and it never you don't take out. Sorry, so you take out it have 12 choice. But the second when you take the second, it already take immediate replace it back immediately, so you have 12. And because the second one have take back immediately, you have 12 choice. It's as a 12 power 3. Okay. And the third one, some students said, I don't get it, teacher. Well, how does this work? The first ball is replaced after it is drawn. Now, let's think about it. we draw the first ball, we have 12 toys, right? And for the second draw, because the first ball have already replaced, already going to. So when you draw second time, it still have 12 ball inside. But you take out the second ball, you remain it outside, means in the third choice, you only have 11 toys. Because the second ball you take out, you don't take it back. So in the third box, you only have 11 toys. If you multi them together, you have 1,584 toys. Nice. Should be the killer queen. Okay, nice. Pretty good. Let's do this 1.54 star question. Can you simplify Pnk, Pn minus Kj, when Kj are integers such as K small or equal than N and J small or equal than N minus K? Actually, this one is not burning time. It'll be more obviously. N minus K factorial multiply with N minus K factorial, N minus K minus J factorial. So in here, this N minus K that will divide by each other. And now you have the N factorial divided by N minus K minus J factorial. Okay? So now here, we can write this thing as a P of N comma N minus N minus should be, let me write this N minus K plus J. So it's should be the here is K plus J. So we done this. You know what I'm saying? About this one. This has expands so much better. That's where I hear background music when I was right. Okay. Okay, cool. Let's check the hint.
I still don't get it though.
Okay, no worries. It's just a very algebra thing, actually. Yeah. If you still don't get it, it's okay. Let me write the answer in here first. Comma. I remember it's K plus J. Let's show the solution. Yeah, N comma K plus J. They use the same way to do this. Okay, this N minus K is divided by each other, and like this, you minus K plus J. So this K plus J. Okay, yeah. For the first version, I did it. I just give you a sequence. This you can see is a +1, and also you see that N plus K, N minus K plus J. So +1. So this part is the same thing as this version actually. Okay. For the first version, I want to make this all expanded, but I think more expanded version didn't help you too much. Yeah. Because it's always +1 really make people confused sometimes. Okay. Okay, this is the 1.454, which you understand what we learned today. Okay. And next part, we're gonna have a review problem. Let's do more review problem, yeah, to check our understanding for one by one. Let's do from the first one, 1.17. Yeah, Dr. Lee is talking in math. Mathless, yeah. The 1.17, let's do this. Okay. For the first one, that's 28. Let me check. Okay, cool. Yeah, not hard at all, right? You can minus 1.5 for each other. So I think it's just minus 1.5. So it will be 1, 2, 3, 4. One minus 0.5 and divided by 3. You will get it. Yeah. How many number are in the list? Second one. $21. Okay. No problem. Okay. Minus 2 divided by 4. Okay, cool. How many three-digit number are divisible by 7? $128. Okay. Okay, no problem. Yeah. Who get 889? Why? 128. Okay. Cool. Need an explanation? Okay. If don't, we pass. Okay. 1.2. 20. Fine. Okay. 5. Okay. No problem. Cool.
Can
Nice
you slow
performance, guys.
down?
Okay. Slow down. That's all. Let's wait for other students for a second. Nice performance, guys, because that's I think you have Can we move on now? Okay, no problem. Let's go. 1.21. Miss Stewart math class has 16 boys. 22 of the students bring their calculator to class. If 13 of the students with calculator are girls, then how many boys didn't bring their calculator to class? Okay. Seven. Okay. No problem. Wait for. You don't get it about this one? Okay, let's think about this one. It said a Stewart math class have 16 boys. So 16 boy. And 22 of the student, they have bring their calculator. So this is 22 calculator. So eliminate is 22 calculator to class. If 13 of the student with calculator are girls, okay, 13 of the student with calculator as girls. We have girls, but we know that 13 of the girls have calculator. So the calculator only 9, okay. And also said this the student math class have 16 boys, and 22 of the students have their calculator in the class, and we don't know how many girls, right? In here, so we think about this thing. We have the 22 minus 13. The 22 minus 13 will equal to 9. Think about the 22 equal to the 13 minus 13. The 22 of the student takes the calculator, right? Because of it's asked how many boys didn't bring their calculator to the class. 那这样的话，we can think about the 22 student takes a calculator. The 13 of them are girls. 13 them are girls taking calculator. So if you use a calculator of 22 minus the girls take calculator, you will equal to 9. You minus this one will equal to 9. And the 9 student is a calculator, takes the calculator boys. So if the boy take a calculator, it's a 16 of the boy. If the boy takes a calculator, it's a 16 of them. If the boy not takes a calculator, it's will be the 16 minus 9 equal to 7. So the 7 without taking the calculator. You understand? Do you understand 1/29?
I don't get how we solved this without figuring out how much people is inside the class.
Okay. Think about this. Actually, you don't need to know actually in here. Because we know boy have 16. With calculator is actually we have the 9 student taking 22 student taking calculator. So for the 22 student taking calculator, you have the boys taking calculator or not having calculator, right? And inside we have the 29 student taking calculator and 13 of the students with calculator are girls. So if you think about this, the 13 of them are girls, then the rest of them taking calculator are 9 what? 9 boys, right? The calculator takes the calculator will be 9 boys. The rest of the part because it's a boy and a girls. Yeah. So we have 9 boys taking calculator and we'll only have 16 boy. So 16 minus 9 will be the 7 boys they didn't take calculator. Are we cool?
Yeah, but I don't get how we got the 9 calculator, people.
You can see in here. Let me rewrite this thing. Because we have 22 students with calculator and have 13 students with calculator are girls.
Oh, wait. Oh, okay.
Have 13 are girls. And with calculator are girls. Girls with calculator. So means this thing to here. Oh, sorry. Should it be the girls? Should it be the girls with calculator divided this, eliminate this calculator? Should the girls with calculator should be the part of its calculator? This 13 in the middle. And the 22 minus 13 will be the 9 with a calculator. But we don't know how many girls in this box actually. But we know, if we know the girls with calculator is 13, yeah, the rest of the part of its calculator must be boys. So we know we have 16 boys. So 16 minus 9 will be the 7 without calculator. Are we cool? Are we cool? Okay, cool.
Yeah.
Okay, yeah. I don't know how the it's not gonna reach quite no, I'm not going to. Okay, 1.2222. 240. Okay, let's try one of our students answer 1.22. Okay, sure. Yeah, no problem. So 5 open shirt, 6 opening pants, 8 opening of hats. So they can just multiply together. Cool. 1.23. How many 3-letter combination from the same answers? Letter must be different from the. Okay. So many 3,002. 3,252. Okay. Let's check. No problem. For the first one, we have we have 26 choice. Yeah, it's because it's the three careful if the second must be 5, so second only 5, and third must different from first, so the 26 multiply 5 multiply 25. 1.24 local theater one thing. This one of the students said so 720. Let's check. Yeah, the local theater was a one ticket window. How many ways can 6 people line up by buying ticket? So 6 people, 6 factorial. Yeah, 6 factorial. The first choice is 6, second is 5. How many can you order 7 different color hats in a row? I think it's a 7 factorial. Okay. Cool, man, guys. 1.26. Basketball has 12 members. Each of the whom can play any position. One point. This I will choose one of the answers that most of the students choose. 95040. 95040. Show solution. Okay, no problem. Yeah. The 12 number issues can play each of the choose of the starting line. Center, power forward, 1, 2, 3, 4, 5. Yeah, there's a P12-5. Okay, 1.27. List all the arrangement for the letter of word T. How many are there? The A is E. Yeah, all the arrangement. Yeah. Obvious, only arrangement is T. Yeah, only one. Submission 1, no problem. And for the question B, someone said 1, 1, 2. This is all the original letters TI. How many start with T? How many start with I? Yeah, I think only 2 choice. How many with T? First T, E. How many with I? Yeah, 2, 1, 1. Yeah, 1, 1, 2. TI, IT. Okay. So list all the arrangement of the ETI. Circle one of the start with E and compare that group with list part B. How many arrangements of ETI with E, with T, with I? How many arrangements there are total? I think C is ETI, ETE, TIE, IET, ATE, EIT, ETI. Two start. Yeah, no problem. This is all the arrangement of the ETI. I think ETI, the EIT. Then we have the TEI, TIE. Then we have the ITE, IET. I think that's all. So how many arrangements of ETI with start with E? 2, start with T2, start with I2. Okay, yeah. So 6 arrangement, and each one start with 2. That's just a 2. Okay, nice. This is the mini 10 at the bottom of the ETI. Mini 10? What is mini 10 about? Okay, these are all the arrangement letter of the word SETI. So many. Let's start with as compared group in the list C. How many arrangements SETI start with S? This how many arrangements are there total? Should be 6. Mini 10, mini 10. Some students said D is a 6, 6 and 24. Let me check. Yeah, should be 6 and 24. It's a full factorial. Each slot have full choice. Yeah, full factorial. And only for this part, if you lock the S and only 3, 2, 1 choice.
Trying to write out everything, every possibility.
Yeah, cool. That's a good way. So how many arrangements are letter for ASETI? So that's 5 factorial. It should be 120. Actually, you write the C is good. The D will be too many. This one will be very hard. Yeah, if you write all of them. But you can try after the class. I encourage you to try, okay? Yeah. Last question, 1.28. Draw a tree demonstrating possible voter for completion is this.
I try to write out everything inside the one with the A's.
Okay.
There's supposed to be like 1,000.
No, not be 1,000, but this one will be be very big tree. Will be a very big tree. Okay. Okay. How many different ways of ballots that will cast a vote for each office? That will be a very big tree, but actually you can finish that. So let's just solve the second question first. How many different ways can ballot to be complete if each voter must cast a vote for each office? Yeah, I think someone write it right. Yeah, there's only 18 choice. 2 for this, 3 for this, 2, 3 for this. Okay. Okay. Okay, so this is today's class, and I will leave you 1.28 as a homework. You can do the rest of the diagram by yourself.